This video covers section 8.3, and in it we are going to learn how to, number one, graph absolute value functions, talk about their general shape, and then secondly, once we have graphed them, we are going to determine how to, when looking at a graph, to find the domain and range of an absolute value function. So if we go ahead and look at this first example, let's now take a look at how we would graph an absolute value function. And I'm just going to start out with the most basic one, and that's the absolute value of x. And so what I did here is I built a little t-table here, and we're going to go ahead and fill it in. If x is -3, then we would see that the absolute value of -3 is 3. If x is -2, the absolute value of that is 2. If x is -1, the absolute value of that is 1. And the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. And the absolute value of 3 is 3. Which really, these are like our y values. So each of these calculations, for example, when we did -3, that's equal to the absolute value of -3, which is 3. This is how we came up with that value. You can do this sort of calculation for each one of these. It's not really necessary, but what we get is we get a point. We get the point -3 for x and 3 for y. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. And 3, 3. And these are points that are solutions to the absolute value function f of x equals the absolute value of x. And so I'm going to go ahead and put them on a graph here. And let's see what kind of shape this thing has. And we go ahead and put our points on. We see a shape that looks kind of like a V. Let's go ahead and label our points, because we should always label points. -1, 0 over here. And you, as I mentioned earlier, you kind of have this nice V shape. In fact, every absolute value function will have this sort of shape. Now, they're not always in the same exact place, but they should always have the sort of V shape. Sometimes they open up, sometimes they open down, sometimes they're shifted right and left or up and down, but they all have this basic shape. Now, anytime we're talking about a function, again, we need to talk about the domain and range. We can see here that for the x's, we have points that go forever in both directions for x. So the domain is -infinity to infinity. It keeps going out to the right and left. However, we are limited for the range. There are no points that go below the x-axis, and so the range is only the positive y value. So this is going to look like 0 to positive infinity for the range. Alright, so this example is a bit different than the last one because we have some shifting going on. Let's start out the same way though. Let's take our table of values like we had in the last one, and let's plug in some different x values here. So if we take -3 for example and plug it in, when you plug negative 3 in for x, negative 3 plus 3 is 0. 0 minus 4 is negative 4. Again, all I did there was I was finding f of negative 3, which is the absolute value of negative 3 plus 3 minus 4, and that's 0. 0 minus 4 is negative 4. I'm not going to show the math for all this. Basically, I'm just plugging negative 2 in for all these. So when I plug negative 2 in here, I get negative 2 plus 3 is 1. 1 minus 4 is negative 3. When I plug negative 1 in, I get negative 2. When I plug 0 in, I get negative 1. When I plug 1 in, I get 0. When I plug 2 in, I get 1. And when I plug 3 in, I get 2. Now, notice the problem here is if I start to put these points on, negative 3, negative 4, negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, 0, 2, 1, 3, 2. This is an absolute value function, so we expect, just like in the last example, that we should have some sort of V shape. All we have so far is just a line. So, and it appears as I keep going further and further to the right, this line is just going to go up. Maybe we should see what happens to the left over here. So, you know, this value right here is at, what do we say, negative 3, negative 4. So maybe I should try plugging in a value to the left of that value, like x equals negative 4. Negative 4 is the next value to the left over here. If I plug in negative 4, I get negative 4 plus 3. Negative 4 plus 3 is negative 1. Absolute value of negative 1 is positive 1. 1 minus 3 is negative 3. So we have negative 4, negative 3. Now we're starting to go in the right direction here. Starting to see that V shape happen. So maybe one more value, negative 5. If I plug negative 5 in, negative 5 plus 3 is negative 2. The absolute value of negative 2 is positive 2, and 2 minus 4 is negative 2. So we have negative 5, negative 2. Put some of these points in over here. This was 1, negative 2. This was 1, 0. This was 3, 2. You get the idea. This graph should look something like this. Okay, and again we see that V shape. It's in a different spot. This graph is different than in a different spot than the last one. Again though, we can talk about the domain and range just like the last one. It turns out pretty much actually every absolute value function has the same domain, because you can plug in any x value in here. It doesn't matter what it is. Notice that this graph keeps going out here to the right, keeps going out to the right, and it keeps going out to the left as it goes up. So domain is again everything. It's negative infinity to positive infinity. But when I'm talking about the y's, the range here, it's not everything. Yes, the graph does continue to go up to positive infinity, but it stops down here. Where does it stop? It stops at negative 4. So the range is everything from negative 4 to infinity. Now I already mentioned this graph in comparison to the last one is different. It's the same shape, it's the V shape, but this one, if you will, it starts here at 0, 0. In fact, we call that point right there, it has a special name, it's called the vertex. Well, in this graph the vertex is at 0, 0. In this graph the vertex is at negative 3, negative 4. Now, look at what's going on here. It looks like that if I take and look at the opposite of this positive 3 that's added to the x, so it's x plus 3, well, it turns out that this means that there is a shift left by 3. You always have to kind of think about it in the opposite. So if that's positive 3, normally think of positive as going to the right. Well, it turns out that positive, we're going to go to the left here. And then the part that's outside the absolute value, this minus 4, that gives us a shift down by 4. And so what we can do is take that last graph. Let me just kind of sketch it real quick here in green. Remember, it looked like this. It was still the V shape, but it had the vertex at 0, 0. Basically, we just take that whole graph and we shift it left 3 and down 4, and we get this new graph. Let's take a look at one more of these. Similar idea, just one thing that's slightly different. Just like the last one, remember, whatever is going on with the x, we think the opposite. So since this is x minus 1, we're going to be doing a shift right by 1. And then the part that's outside the absolute value, that's the up or down shift. So this is a shift up by 5. Now the other thing that's different is then that last example, the absolute value is just a positive absolute value here, and here in the second example, I guess it's the third example, this is a negative in front. Well, what that does is it makes the graph open down. It flips it upside down. Whenever you see the negative out front there, it's going to flip the graph upside down. So let's use this idea of shifting this time. Rather than going out and trying to find points right away, let's start the graph at 0, 0, and let's shift right 1 and up by 5. That takes us to that point right there. That's the point 1, 5. What I'm saying is I expect this graph that for this right here, this point to be the vertex, and I expect the graph to open down, to come down like this. And we can verify this by doing a few points here. If we choose x, and then we find the negative absolute value of x minus 1 plus 5. So this is when x equals 1. The next value to the left here is 0. If I plug 0 in, 0 minus 1 is negative 1. The absolute value of that is positive 1, but then there's a negative out front, which makes it negative 1 again. If we add negative 1 to 5, we get 4. Next point to the right, if I go to the right one, that would be 2. If I plug 2 in here, 2 minus 1 is 1, but there's a negative out in front, which makes that again negative 1. Negative 1 plus 5 is 4 again. So we just found, here's the point 0, 4, and we have the point 2, 4. Okay. Another thing that we haven't mentioned yet that I want to mention now is that when we have absolute value functions, we have this kind of symmetry going on. That about this vertex, notice, go back to the last example. Here's my vertex here. These points over here are mirror images of each other across this kind of vertical imaginary line that goes up through the vertex. So if there's a point up 1 over 1, then there's another point up 1 over 1 over here. If there's a point, this point right here, 1, negative 2, that's up 2 over 2. Then there's got to be another point on the left side up 2 over 2. And so it turns out this graph is going to, there's going to be another point here. This graph is going to come down like this. We again want to talk about the domain and range of these two. Domain for the first, it's again negative infinity to infinity. The range now is a little different. We're not going up to infinity this time. The graph is opening down, so it's going down to, you guessed it, negative infinity. So this is going to be negative infinity, because we always go from smallest to biggest. Negative infinity, and where does it stop? It stops at 5 with the bracket. And then the last example here, we want to go the opposite way. If we're given a graph, we should be able to find the function. So we know that the basic absolute value function starts at 0, 0. This one obviously does not have a vertex at 0, 0. It's been shifted where? You should say it's been shifted left 6. So remember the shifting right left is controlled by the part that's inside the absolute value. So if we're shifting left by 6, we think the opposite. So we want to have an absolute value of x, not minus 6, but x plus 6. Does it shift up or down at all from 0? Nope, the vertex is right on 0. So there's not going to be anything out here after the absolute value. It's just going to be f of x equals the absolute value of x plus 6. Alright, thanks for your time. We'll see you in class.